Hello students, today I am going to discuss a set theory. Basically set theory is a branch of mathematics, or you can say it is a part of mathematics. Okay, so first of all we need to understand what is the set. Okay, simply think any collection is called set if it is well defined. Okay, any collection is called set if it is well defined. If it is not well defined, then just you can say it is a collection, not a set. Okay, so a collection should be well defined to become a set. Okay, it means what is the meaning of well defined? Well defined means simply if a particular object or particular element belong to that set or not. Okay, for example, if I am saying that a collection of all intelligent student in BCA section A, suppose, so the term intelligence is not well defined, because if a particular student or is intelligent in a particular subject or particular topic, it quite possible it is not well, or it is not intelligent, or he is a weak in another subject or another topic. So well defined is intelligence is not well defined. Okay, so I'm saying that a collection of objects or collection of elements or collection of numbers is called set if it is well defined. Okay, so if you can see the set of all students in BCA, it is a well defined collection. But if you say the intelligent student in BCA, it is not well defined. Okay, so if you collect the all intelligent student, it not form a set, it's just a collection. Okay, simply. So I hope it is clear of you that what is the set. Set is a well defined collection of objects. Okay, now we have some standard notation to denote a set. Basically, when we define a set, the notation of the set is usually used with the help of capital alphabet. Suppose A, S, like that, and the elements of the set usually denoted by the small alphabets A, B, C, D, like that. A, B, C, D, X, Y, Z. Okay, so if I write a set S equal to, in the curly braces, A, B, C and D, X, Y and Z, this is a set. This is the collection of A, B, C, D, X, Y, Z. This form a set. Okay, and these A, B, C, D are called the elements of the set, or you can say the objects, or you can say the observations or numbers and all. Okay, so these are called the elements of the set, and usually you can I have told you these denoted by the small alphabets, and the set represent is the capital alphabet. Okay, now uh, definition of set. As we have already learned in the introduction, set is a well-defined collection of objects or pupils. Set can be related to many real-life examples, such as number of rivers in India, number of colors in rainbow, etc. Okay, so number of rivers in India is a well-defined. Number of colors in rainbow is well-defined. Okay, so this is the well-defined collection of objects or rivers or rainbow. So you can say or colors. You can say this is all these objects form a set. Okay, now representation of set. Usually we have two type of representation of sets. One is roster form or tabular form, and second one is set builder form. Okay, so in roster form, basically we write in tabular form or roster form of roster form. Yeah, the elements written in the roster form or tabular form. So we can say this is roster form. And in the set builder form, we write the elements as x such that x, okay, in the form of set. Okay, so simply you can say if I write a roster form, or you can say tabular form, it means if I write a collection of all numbers from 1 to 10, 1 to 10. Simply I can write s equal to 1, 2, 3, 4, 5, 6, 7, 8, 9 up to 10. This is the roster form. Okay. Similarly, if you want to write the alphabet from A to Z, you can simply write in the roster form. But if you want to write this 1 to 10 in the roster form, sorry, set builder form, then simply you can write s equal to x in the curly braces such that x is, or you can write x lies between including 1 and 10. Okay, this is the set builder form and this is the roster form. Okay, so and you can take another example. Suppose if you want to write the all alphabet, so you can write s equal to a b c d a b c up to z. Okay, this is the roster form or tabular form. You can write this thing as s equal to x such that x is s x is a to z. So again a set builder form. Okay, simply as you can see here, example, if a set represent all the leap year between the year 1995 and 2015, then it would be described using the roster form. Simply you can write a equal to 1996, 2000, 2004, 2008, 2012. Okay, so this is the roster form. Now the element inside the braces are written in ascending order. Okay, this could be descending order or any random order. Okay, as discussed before, the order does not matter for a set representation in the roster form. If you want to write if you change the order of these elements, suppose you can write 10, 9, 8, or you can write 2, 3, 5, 6, 8, 9, 1. It is you can simply write all these elements. Okay, so order is decreasing or increasing or random order is not matter in the form of roster form. Okay, now set builder form, as I have already discussed. In a set builder form, all elements have a common property. This property is not applicable to the object that do not belong to that set. Okay. For example, if a set S has all elements which are even prime numbers, even prime, it is represented as S equal to, simply you can write S equal to x such that x is an even prime number, even prime numbers, simply you can write. Okay, so this is the set builder form. Set of if you want to write all even prime number, or you can simply write the two digit numbers, even and two digit or one digit. So it means you can simply write two digit number from 10 to 99. Okay, which is a bounded condition because 10 and 99 is the upper and lower bound are there. Okay, now you can see another example, f equal to p such that p is a set of two digit perfect square numbers. Perfect square numbers means 6 and 2 digit. Here you can see the mentioned two digit perfect square. So 2 digit perfect square, first number is 16, then 25, then 36, then 49, 64 and 81. These are the two digit perfect square number. Okay, because condition is two digit only. Okay. Okay, now type of sets. There are different type of sets. First, you can see here the set are further categorized into two different types based on the elements or type of elements. These are different types of set in basic set theory are finite set. Finite set means a set have finite number of elements or finite number of objects called finite set. If a set has an infinite number of elements or infinite number of objects, then you can say the set is infinite set. For example, a set S has suppose 1 to up to 1000. Okay, this is a finite set because the number of elements or number of objects are finite in the set. But if you write a set, suppose n equal to one set of natural number 1 to and so on up to infinity. This is the infinite set because set of natural number are infinite. Okay, so this is the finite set and this is the infinite set. You can take another example of infinite set. Suppose set of integer, set of real numbers, set of complex numbers, set of rational numbers are all the example of infinite set. Okay. Now, next one is empty set. What is the meaning of empty set? If a set has no element, then the set is called the empty set. Simply, you can write the empty set as denoted by phi. Okay, or you can write in the curly braces. This is the notation for empty set. Okay, you can't write s equal to 0. This is not empty set because 0 is an element. Okay, some student confuse about this, so I write here this of 0 is an element. So if element has one, if a set has only one element, this is 0, then this is not empty set, it's a set of one element, or you can say this set of singleton. The set is called the singleton set because set has only one element. Okay, so empty set usually noted by this notation phi or empty curly braces. Next, singleton set. It has only one element. If a set has only one element, then this set is called the singleton set. For example, S equal to suppose A, a single element. Okay, this type of set is called the singleton set. Now, next one is equal set. Two sets are equal if they have the same number of elements. Okay, if they have the same number of elements, then you can underline this same number of elements. Okay, but in case of equivalent set, two sets are equivalent set if they have the same number of elements. Okay, here two sets are equal if they have the same element and here same number of element. Okay, so two sets are said to be equal if two sets, suppose a set S1 has A, B, C, D, and another set S2 has element A, B, D, C or A, B, C, D, then S1 equal to S2. Okay, but if a set suppose S3 has 4 element 1, 2, 3 and 4, then S1 and S3 are not equal but they are equivalent. Okay, because the number of element in S1 and S3 are number of elements are same but elements are different. Okay, so if two set have same element, then the set is called the equal set, and if two set have same number of element, then you can say the sets are equivalent. So S1 is equivalent to S3 and again S3 is equivalent to S2. Okay, now next, power set, a set of every possible subset. So first you need to understand what is the subset. So what is the subset? Subset means what? A subset basically every set is a subset of itself. Okay, or you can say a set is called the subset of set A. Suppose if if it is equal to A, or if it has the same element or equal element to A, or at least one element less than the set of A. Okay, and the elements of subset and elements of set are the should be same. So for example, if a set S equal to, suppose, have A, B, C, D, E and F, suppose this is a set, then a subset S1 again has A, B, C, D or E. Okay, so S1 is a subset of S, or you can say S1 is a proper subset of S. Okay, as I have told you that every set is a subset of itself, so S is a subset of itself. Okay, but in case of proper subset, then S1 have at least one element less than the superset. Okay, this S in this condition is called the superset, and S1 is called the subset. Okay, so how many subset are possible if a set have a number of element is n? So suppose that for example I have a set A, and suppose set A has three element 1, 2, 3. Then how many subsets are possible of set A? So suppose first the subset contain only one element, and another set contain only two, and third subset contain only three. These are the subsets of set A, because the elements of subset belong to the set A. So these are the singleton set and subset of set A. And another one is 1, 2, another subset, and 1, 3 and 2, 3. Okay, these all are the subset of a set A. And as I have told you, every set is a subset of itself. So again we can write 1, 2, 3 is a subset of set A. Okay, and one more thing, empty set is always subset of itself. Sorry, empty set is a subset of every set. Okay, so we can write here 5. Okay, so these 1, 2, 3, 1, 2, 1, 3, 2, 3, 1, 2, 3 and 5 all are the subset of a set A. Okay, if we write the collection of all subsets in the form of set, then this collection is called the power set of set A. Okay, then this the collection of all subset of a set A is called the power set of A. As you can see here, the power set A of every possible subset. Power set means a set of every possible subset. Okay, so if a set A has three elements, then the total possible subset of set A is 1, 2, 3, 1, 2, 1, 2, 1, 3, 2, 3, 1, 2, 3 and 5. Okay, so this is called the power set of set A. Now the number of element in set A is equal to here 3. Okay, and number of elements means the cardinality of the set, and number of elements in power set of A, how many? You can see here 8. So number of element in power set of A is 8. Okay, 1, 2, 3, 4, 5, 6, 7, 8. So you can write 8 as 2 to the power 3. Okay, so in general, number of elements in a power set of a set A is 2 to the power n, where n is the number of element in the set A. So in general, cardinality, or you can say the number of element in power set of A in the power set of A is equal to 2 to the power n, where is n is a number of n is a number of elements in the given set A. As you can see here, number of element in A is 3 and the number of element is power set of A is 2 to the power 3. Okay. Now next, there are some symbol of set theory. Okay, so as I have told you that n, capital N, denote the set of natural numbers. Is the basic notation. Okay, and so 1 2 3 up to infinity, and capital Z denote the set of integers, capital Q denote the set of rational numbers, capital R denote the set of real numbers, capital C denote the set of complex number. Okay, so these all are the infinite set. Now some notations. There are some notations to represent a set. So usually we denote when we define a set, then we use the curly braces. So if I write s equal to, so we can write the elements of the or objects or the numbers of sets in the form in between the curly braces. So if I write the object, suppose a b c d in curly braces. Second one is union. Union basically is the operation of set. Basically, as in the mathematics we use the addition and subtraction to add or to subtract the two numbers. In the similar manner, we use the union and intersection when we calculate and when we try to do the operation of the set, we use the union and intersection. Okay, so this notation just A union B, and this notation A intersection B, and this notation I will discuss in later in detail what is the meaning of union, what is the meaning of intersection. And if we write A is a subset of B, then simply I can write this sign, and if we write A is not a subset of B, simply we can write this type. And if I write A is a proper subset of B, then simply we can write A is a proper subset of B. Similarly, if I write A is a superset of B, then we can write simply this type. And as I have discussed, phi is a null set, and power set of a set, suppose a set A, then the power set of A is denoted by P of A. And if two sets are equal, then we can if two sets A and B, then if they are equal, then simply we can write A equal to B. And the complement, simply we can write A to the power C or A dash. This is the notation of complement. By the meaning of complement I will discuss. And if a particular element belong to set A or set B, then simply we use this notation. Suppose that a set A equal to A, B, C, D have 4 elements, then I can write small a belongs to capital A. It means the set is the element small a is an element of set A, capital A. Simply you can write B belongs to capital A, C belongs to capital A, and similarly D belongs to capital A. Okay. Next one is not belonging to. If you suppose I can write here A B C D E. E is not E does not belongs to set A. So simply we can write E does not belongs to set A. Okay. Now next, some standard formula of set theory. I'll discuss later what is the meaning of an A union B and how to use this and what is the application of all these. Simply you can see here A union B, number of element in A union B is equal to number of element in A plus number of element in B minus number of element A intersection B. It means number of element common between A and B. Okay. So if I need to calculate the number of element in A intersection B or A union B, then we can use this formula. Okay. So suppose a set A has three element 1 2 3 1 2 3, and suppose a set B has A B C D A B C D. Then what is the meaning of A union B? A union B means all elements belongs to A and B. Okay, so 1 2 3 4 1 2 3 ABC ABC, sorry, ABD ABD. Okay, and the meaning of A intersection is that A intersection B means the common element between A and B. As you can see here, set A has three elements AB, sorry, 1 2 3, and set B has three elements ABD. There is no common element between A and B, so you can write simply A intersection B is empty set, or simply you can write phi. These type of set, if two set intersection of two set A and B equal to empty or phi, it means set A and B have no common element. It means they are disjoint set. Okay, this type of set is called a disjoint set because they have no common element. Okay, so if I need to calculate the A union B, simply we can write number of element in A plus number of element in B minus number of element A intersection B. So as you can see here, a number of element A union B 1 2 3 A B D. It means number of element A intersection B equal to what? 6. Okay, and with the help of this formula, as you can see, number of element in A is 3 plus number of element in B is 3, and number of element minus number of element in A intersection B is 0, which is equal to 6. As you can see, number of element in A union B is equal to 6, and you can see here number of element A union B is again 6. Okay, now as you can see, the second point, number of element A union B equal to number of element in A plus number of element in B. When A and B are the disjoint, it means if A and B have no common element, so you can simply skip this part because number of element A intersection B equal to phi, or it is an empty set. Now number of element in U equal to what? U is a universal set basically. Okay, and number of element in A plus number of element B minus number of element intersection B plus number of element A union B complement. This is a sign of complement. You can write here C in upper side. Okay, I'll take one example to understand this, and you can see the next point, number of element in A union B equal to number of element A minus B plus number of element B minus A. It means what? Number of element A minus B means the elements contained in A not in B. Okay, in the similar manner, number of element in B minus A means number of element contained in B not A. Okay, I'll discuss in detail further. As you can see, the number of element is A complement. A complement means the number of element in the in the universal set minus number of element in A. Okay, as I'll discuss just okay, so union means what? Union means what? Suppose this is a set. Suppose this is a set, and it's had 1 2 3 4 5 6 7 8 9 10. Okay, and this is the universal set. Suppose this is the U, capital U, and suppose I have take these four element only. Okay, this four element. Okay, so what is the meaning? And suppose these four element, the set of these four elements, suppose A, capital A. So here you can see U equal to universal set 1 2 3 4 5 6 7 8 suppose, and A equal to only 1 2 4 and 5. Okay, so if I need the to find the complement of A, so simply we can write A complement. Okay, it means what? Union, sorry, this universal set minus set of A. Okay, so number of element in A complement means what? Number of element in the universal set minus number of element in the set A. Okay, so in this case, number of element in 1 2 uh, 1 2 3 4 5 6 7 8, and in A 1 2 4 and 4 and 5. Okay, so what are the elements in A complement? A complement has only those elements contained in union but not in A. So you can remove 1 2 4 and 5, so simply you can write 3 6 7 or 8. So total number is 4. 1 2 3 4. Okay, this is the meaning of A complement. Now next one is some operations. As I have told you, there are some basic operations. There are four important set operation that we are used widely. First one is union of two sets, intersection of sets, complement of sets, and different of two sets. Okay, so what is the meaning of union? As I told you that if a set A suppose have some elements 1 2 3 and 4, and suppose another set B has four element 3 4 5 and 6. Okay, then if I need to find the union of A union B, it means all the elements belong to set A and set B but not repeated. So I can write simply 1 2 3 4 5 and 6. This is the A union B. Okay, and if I need to find the intersection of two sets or intersection of A and B, so simply I can write A intersection B equal to only the element only those element in intersection which are common in A and B. So as you can see, common elements are 3 and 4 only. 3 and 4, because 3 and 4 belongs to both set A and B. Okay, so this is the intersection B, this is the A union B. Now I write here the complement of set. Okay, so complement of a set, as I have told you that suppose we have a universal set, and set has 1 2 3 4 5. Okay, then if I need to find the A complement, so we denote the A dash, or you can write simply A complement. So A complement means what? A complement means what? The U minus A, universal set minus A. Okay, so only those elements belongs to U, not belongs to A. Okay, so you can write simply 3 and 4. Okay, now different of two sets. So if I need to find the A minus B or B minus A, A minus B means what? All those element belongs to A, not belongs to B. Belongs to A but not belong to B. So 1 2 3 4, and you can see here only 3 4. So belongs only A but not in B. So you can write here only 1 and 2. I hope it is clear all of you that what is the meaning of A intersection B, A union B, complement of two sets, sorry, complement of a set and different of two sets. Now some fundamental properties of a set operations, as I have discussed already, like addition, multiplication operation in algebra. The operations such as union and intersection in set theory obey the properties of associativity, commutativity, and also the intersection of two sets distribute over the union of two sets. Second one is sets are used to describe one of the most important concept in mathematics, that is functions. Okay, everything that you observed around you is widely the mathematical models which are related to the which are related and we can solve easily with the help of functions. Okay, so this is the basic. I'll discuss in detail with the example all these things. What is the meaning of multiplication? What is the meaning of associativity? What is the meaning of commutativity? Okay. Just a brief introduction about the associativity and commutativity is that, as you can see in algebra, I can write a plus b equal to b plus a. This is called the commutativity because two elements are commute. Okay, in the similar manner, if I write a union b, then it is equal to b union a. This is called the commutativity. Okay, and in similar manner, associativity means what? In algebra, I can write a plus b plus c equal to a plus b, a plus b plus c. Okay, so you can write simply in the form of unions: a union b union c equal to a union b union c. This is called the associativity property of union. Similarly, we can use the property of multiplication and intersection property in the set theory. Okay, now we have a problem and solution. As I have already discussed, if U is a universal set and contain A, B, C, D, E, F, and A is a set contain only three elements A, B, C, and B is another set contains C, D, E, and F, and C is a third set contains C, D, and E. Find A intersection B union A intersection C. So first of all, we need to find the A intersection B. It means we need to find those elements belongs to A and B, okay, which are common in A and B. So as you can see, A has A, B, C, and B has C, D, E, and F. So common elements of A and B are only C, is only C. As you can see, only the one element C. So A intersection B is C. Now we need to find the A intersection C. As you can see, capital A has ABC and C has CDE. Okay, so you can see the common element between this set A and this set C is only this alphabet C. Okay, so common element or intersection of A intersection C is only C. Now to find A intersection B union A intersection C, because in A intersection B is only C and A intersection C is only C, so A intersection B union A intersection C is only C, because in the union we take the all elements belongs to set A and set B. Here set A means A intersection B and set B means here A intersection C. So all elements only because you can see here these two sets has only one element which is C. So A intersection B union A intersection C is equal to only C. Okay. Now you can see here another example. If you take u equal to 2, 3, 4, 5, 6, 7, 8, 9, and 11, and a equal to 3, 5, 6, 3, 5, 7, 9, 11, and b equal to 7, 8, 9, 10, 11, then find a minus b complement. Okay, so first of all we need to find the a minus b. A minus b means what? A minus b means what? A minus b means what? All those elements belongs to it but not belongs to b. Only belongs to A but not belongs to B. Okay, so A minus B is what? The elements belongs to A, not belongs to B. So you can see here only 3, 5 are the element which are belongs to A but not belongs to B. Okay, as you can see here 3, 5, 7, 9, 11 minus 7, 8, 9, 10 or 11. So you can see here 9, 7, 9, 7 belongs to A and B both, but we need to contain only those elements which are belongs to A but not belongs to B. So these are 3 and 5 are the only element. Now we need to find the complement. Complement means what? Complement of set A, as I have told you that universal set minus of that set. Okay, so A minus B complement means universal set minus A minus B. Okay, so it means what? It means those element contained in U or universal set and not belongs to A minus B. Okay, so as you can see, the elements in A minus B is 3 and 5 only, and the elements in U is 2, 3, 4, 5, 6, 7, 8, 9, and 10. So only the element belongs to U but not belongs to B. So we remove 3 and 5 from the U, 3 and 5. So the remaining elements are 2, 4, 6, 7, 8, 9, 10, and 11. Okay, so this is the complement of A minus B. Okay guys, thank you so much for watching this, and if you have any type of confusion, and if you have any type of doubt, then let me know. I'll discuss in later, and I am trying to solve more and more question about the set, and it is depend on the set operations. Okay guys, okay, thank you again. And if you need to suppose you need to take any you need to solve more and more question related to this concept union and intersection and complement, and if you have doubt, let me know then. Okay, okay, thank you again.